Okay, we've got something slightly more challenging because we're going to try to solve one with 3 vectors and find the resultant using trig. We're going to do a sketch. One thing we notice is all 3 of the magnitudes are similar in length, so we're kind of looking at maybe a box even. However, the directions may not form a box. We'll have to see how it turns out. Sometimes they cross and make it look like a bow tie. Sometimes they make a box or a diamond. So we're going to start with our baseline. I'm just going to put it in the middle since I really am not sure where this thing's going. It's going to be the longest, west 38 degrees south. So here's my 38 degrees. I'll make sure it's longer than the other ones a little bit. Looks pretty good right there. That's a magnitude of 400. Draw my east-west parallel line. This time I'm moving west and then north, but I'm going 60 degrees, so it's going to be a larger angle. 340, not quite as long as that one. I hope y'all are impressed with how straight these lines are. Aren't they pretty? This one's a magnitude of 340. I have to now draw me another east-west parallel line to the first 2. 380 meters. I think this one may be a little shy, but whatever. 380, somewhere between the lengths of those 2 at an east 30 degree north direction, so 30 degrees east and then north, somewhere in this ballpark. That's 30 degrees, and make it in length between those 2, or at least try to. Okay. And that magnitude is 380. Y'all are going to love these because 3 vectors creates twice as much work. Here's where we started. Here's the end. The resultant goes from the start to the end. What you're going to do with these 3 vector problems is treat it and solve the first triangle, because there are going to be 2 triangles, as if there was not a 3rd vector. So really you're going to solve from the start to the end of the 2nd vector. That's how you're going to split it into 2 triangles. So I'm doing a very faint line across there, and so this triangle will be the first one we solve. This triangle will be the second in order to find that resultant. So I'm going to start with having to figure out this. I'm just going to call it X. It's really kind of the resultant of the first triangle. So I'm going to solve for X. I get to start with law of cosines. X squared. I've got my 2 other side lengths, which is 340 squared plus 400 squared minus 2 times 340 times 400 times the cosine of this angle. So that's an angle that I'm going to have to somehow figure out what it is. Well, this 38 has the alternate interior of this being 38. These 3 angles form a straight line, so they should add up to 180. So 180 minus 60 minus 38 gives me an angle of 82. So it's the cosine of 82. So I'm going to go type in my law of cosines. Second square root 340 squared plus 400 squared minus 2 times 340 times 400 times cosine of 82 equals 487.59. So x equals 487.59. Now, that's longer than any of the others. Certainly doesn't look longer than the others by my drawing, which is not to scale, but because it doesn't look like that, I would prefer to go back and just double check to make sure I calculated that correctly. 340 and 400. This was the 60-degree angle that went west and north. This was alternate interior at 38. 60 and 38 is 98. Subtracted from 180 is 82. So all of those numbers should be correct. 340 squared plus 400 squared minus 2 times 340 times 400 times cosine of 82 equals, not that, square root that, 487.59. So basically what I know is I didn't draw a very good drawing. That's the length of this side, 487.59. Now I can figure out, maybe I need to know some other angle in here. I'm probably going to need to know what this little piece is, because when I get over here to my resultant, maybe I'm going to need to know this angle. I don't know. I'm just going to go on and solve for these angles in this triangle. So I've got the 82. I'm going to go on and figure out what this whole angle is. And in order to do that, I'm going to use the law of sines. So I've got the sine of 82 over 487.59 equals the sine of Q over 340. This whole thing is Q across from 340. Handy dandy calculator. 340 times the sine of 82 divided by 487.59. Second sine of that answer gave me an angle for Q of 43.7 degrees. So the whole thing is 43.7. And if that's 43.7, I'm going to add that to 82 and then take that away from 180. I saved myself by subtracting 180. No, my answer for this angle has to be positive 54.3. I'm a time saver, what can I say? I'm an accurate time saver, by the way. Alright, so now we're going to take information from this first triangle and move to the second triangle. I've used law of cosines and law of sines. I can move on to this triangle. Law of cosines, I've got my two sides, but I need this entire angle. Right now I've got 30 degrees for this part. I need to figure out what this little part is so I can add them together to get the entire angle that's going to be across from the resultant vector. I go back to this triangle and realize that this little piece is going to be equal to 43.7 minus 38. Yes, I could do that in my head, but I'm going to go on and type it in the calculator. It's late on a Friday afternoon. I don't want to make a mistake. That's 5.7 degrees. So this little piece is 5.7 degrees, which means this entire angle is 35.7 degrees. Now I've got the entire angle that is opposite of the resultant vector. I've got the other two sides the side lengths for that triangle. So r squared is equal to 380 squared plus 487.59 squared minus 2 times 380 times 487.59 times the cosine of 35.7 degrees. I'll start with my square root. 380 squared plus 487.59 squared minus 2 times 380 times 487.59 times the cosine of 35.7. I already hit the square root, so I've got an accurate length of 284. Let's round it to 285 based off the decimals we've got. That's meters. And BTW, I realize now when I was double checking that I wasn't even finding the length of this R. I was finding the distance across, which makes sense that it was longer than those. It does look longer. Checked myself for nothing. Should have known I was right. Alright. The last thing we've got to do is figure out the angle of this resultant. By the way, the resultant angle is always going to be less than 90, so you've got to find the angle that's less than 90. So I will not find this obtuse angle over here. I've got to find the angle inside that's less than 90. So I'm going to use law of sines and go with the sine of 35.7 over 285 is equal to the sine of good old question mark over 380. Times sine of 35.7 divided by 285 gets my decimal. Second sine of that decimal is 51.1 degrees. That's my question mark. What I have to think about is that the actual angle from the east-west line? That's actually not the angle all the way to the east-west line. It's that angle plus this little piece, which is 5.7. So I'm going to add to that the 5.7 degrees, and my resultant angle is going to be 56.8 degrees. So my final answer for that resultant is 285 meters. Need to figure out the direction. Well, it had to move west and then up towards the north. It moved 56.8 degrees. There you go. A reason to draw your pictures plenty big is because look at all these small spaces. I also might recommend that you get a straight edge as well to draw these pictures.